So today we are going to focus on functions. So the first question from tutorial sheet 2 is, let a be equal to what we have there in the bracket, 0 1 2 3, b equal to negative 2 negative 1 0 1 2. Which of the following set ordered pair represent a function from a to b? And for each pair, state the domain and the range. So then the last part is saying you can represent the ordered pairs in form of an arrow or in form of the arrow diagram to see the picture. So how do you define a function? This is what we call mapping. Now, there is what we call a domain and range. This is where now, when you want to understand the domain and range, you use this relationship here. It comes from here. So if you're going to understand it from here, it's going to be very much easy for you to understand the domain and the range. Okay, now there we go. We know that when we're talking about the mapping, for example, if we have the first one here, we have got the first part here. Let me put it here. Okay, the second part here. So under mapping, you always have the x and y. The x in this case, this is the domain, and this is your range. There is no debate about this. So whenever you hear the word domain, we are talking about the x values. When you hear the word range, we are talking about the y values. If I've got a graph, then this graph goes like this. The range, these are y values, meaning that the range is starting from this point here all the way, we don't know where it's ending, to positive infinity. The x values, this graph is open. This side we don't know where it's going to end, this side we don't know where it's going to end. So it's from negative infinity all the way to positive infinity. That is the domain. Now, when you've been given a mapping, one thing you have to understand is that this is the x and that is the y. This is x, that is y. This is x, y, x, y. So if I want to map this, meaning that in x values, what do we have? We have got 0, 1, 2, 3. So I'll start here. I'll write 0. Okay. I'll write there 0, 1. Okay. What else do we have? We have got 2, then 3. What of the y? The y, we start from negative 2. We have negative 2. What else? We have 0. What else? We have 1 and 2. So if we were to map this, we can clearly see that 0 maps to 1. So 0 here has to go to 1. Now, if I come, 0 has to go to 1. Okay? Then 1 has to go to negative 2. 1 to negative 2. 2 to 0. 2 goes to 0. Then 3 goes to 2. 3 goes to 0. Before we continue, do we have any question there? We are okay, right? Okay. Now, when you map these guys, the next thing is you need to define a function. A function is the same as if I can give you to say, if this is the house, okay? For you to define that this is a function, for you to define that this is a function, when we're talking about the domain, when we are talking about the domain, we are talking about the domain is the same as the husband. want you to understand this. The range is the same as the wife. What do I mean? A man is possible he can have 2 or 3 wives, but it's not possible for a wife, for a lady, to have 3 husbands. Forget about room 18, but let's just talk about the genuine issue here. A wife, a lady can only have 1 husband. That is a range. What does it mean? I'm saying that the domain is the husband, the range is the wife. A man can be able to have 3 or 2 wives. It's normal. A lady can only have 1 husband. That's normal. Okay? Now, one thing we need to understand here is that it is possible that we can have 2 values of x mapping to only 1 value of y. That is a function. You can have many values of x mapping, but the output should only be 1. You can have many values of x, but the y value should only come out as 1. Is that okay? What do I mean? What I mean here, guys, is this. If I have got 2, 3, 0. These are x values. Let me not put 0, let me put 5. So if these are x values, then I've got the y values as 5, 6, 8. It is possible that all these values, they can just go to 1. That is a function, because we are saying that this is a man, okay, this is a husband, this is a wife, sorry. Is it making sense first before I continue? Maybe I use another example. Are you guys getting me? So now, what I'm trying to tell you guys is this. It is possible 2 values of x can give us 1 value of what? Y. Perhaps you have seen a quadratic equation where you have got x squared is equal to maybe 4. Then you say x will be equal to plus or minus 2. And for sure we have got negative 2 and negative y. Negative, positive 2. Of which if you plug in these values there, you still get 1 value of y. Okay? Now, the question here is, we want to know, is this a function? Now, you can only know that this is a function if 1 value of x maps to only 1 value of y, or 2 values of x goes to only 1 value of y. That is a function. It's okay. So what we have here, is this a function based on the definition which I've given you? It is a function. Anyone who is behind there? Don't you think that the example which I gave you about the husband and the wife have swapped? You're wondering the same, right? Yes, I've swapped. Because if we have got 2, 5, 8, then here if we have got 1, 2, 3. So we are saying that you can have many values of x mapping to only 1 guy. So I've swapped the example. So now, meaning that this has to be the wife and this has to be the man. What does it mean? A man can have can have 2 or more wives, which is possible. You can clearly see that 2 here is just alone. but is standing against 3. So the example which I gave you, I swapped. So in short, the x values, that is a wife, then the y values is a, or you can say a man, then this is a woman. As long as you remember this example, it's going to be easy for you to remember the mapping thing. So if you have been given this and then you just know that if one value of, you are supposed to get only one value of y, that is okay. Okay, so let's go to the next one. I'm going to do this the last one. I want to see which one cannot be the function. Let's see. We have got in x, these are x. So in x we have got 0, 1, what else do we have? 2 and 3. This is x, then y. What do we have in y? In y we have negative what? Neg 2, neg 1, what else? 0, then 2. So 0, negative 1, 0 to negative 1, then 2 to 2, 2 to 2, 1 to negative 2, 1 to negative 2, 3 to 1, 3 to 1. Is this a function? Is this a function? Why? Why is it not a function? Okay, you just know that it's not a function, but you don't know the two values of what? But isn't that okay? You can have two values of x. You can have two values of x mapping to 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 one value of y. That is just okay, because those are ladies. They can get married to just one man, the same man. It's fine. But we have got, there is a guy here which is not mapped to anyone. So is that a function? Come on, I know you did this, so now I'm asking you, it would be more like a revision now. The question is this a function? Why? The 0 in the y value is not mapped, so that's the reason why it's not a function. So our friend there is saying that is not a function because 0 there has not been mapped to anything. Are we in support with that? Okay, someone has got a question. In short, what we are trying to say here is, guys, when it comes for this mapping, if you want to understand what is happening here, is this. Let me give you a general. It's like you have got the equation which is x squared minus 9 is equal to 0, and you are trying to find the value of x. Okay, so if we find the value of x here, I want you to know this. is going to be equal to 9, of which x will be equal to plus or minus what? 3. We know that, right? That would mean to say I've got two values of x, but of which if I say y is equal to x squared minus 9, even if I put 3, even if I put negative 3, even if I put positive 3, I'll end up having one answer. Not so. I'll end up having y is equal to 0. Meaning that I can have two different answers. I can have two different values of x, giving me only one answer. I can't, it's not possible to have two answers for y. You get my point, eh? But for x, it's fine. You can have a lot of values. You can even have three, mapping to just one value of y. It's fine. That is still a function. Is that okay? But again, it's not possible, at least for all the values of y, they are supposed to be mapped to something. Then we can consider that as a function. Now, 0 is not mapped to anything, so it's not a function. Okay? It's not a function. 0 is not mapped to anything. But it is possible. I think you have done radical equations, right? Have you guys done radical equations? Have you ever come up with the answer? When you find the answer and then you plug in the answers, you say this is not part of the solution. You have come across such, right? Exactly. So if you have come across such, meaning that you can have a number here in x not mapped to anything to y, is fine, meaning that's not part of the solution. But at least all the values of y, they're supposed to be mapped to any value of what? X. But you can have a value from y not mapped to anything. That is okay, still a function. Is that okay? So this is not a function. What I'm trying to tell you another thing is this. I think, let me just give an example, but you can do number 3 and 4. I want to give you an example of if you have 2, 3, 5, and then you have got 3, 7, 9, like this. If you have this, this is still a function. Why? Because all the values of, we just want the output should be mapped at least to any value of y. It's fine. But this is not a function again, because one value of y is giving us two values of, one value of x is giving us two values of y, which is not possible. But what I mean is it's supposed to be like this, or maybe let me just remove 9 here, like this. Now one value here is not mapped to anything, but at least all the values of y, they are mapped to the values of x. So still that is a function. You discover to say you have got, you have find an answer, you plug in the values, it's not going to give you the answer. You say it's not part of the solution, but still it's a function. Is that okay? And I explained this using that video which is on the website under relation, mapping and relations. I explained this. So if you manage to watch that video, I believe you'll be able to understand this. But I think you have gotten something. Anyone who has got a question? Now here they are saying state the domain and range. The domain, these are just values of y. So you can say the domain, then you say domain for the first one is 0. You say 0 comma, you put them in like that, 0, 1, 2, 3. That's a domain. Range, the values of y, you list them. Any question before we go to the next question? We're okay, right? Guys, we are good to go. So, and then if you understand, listen guys, if you understand the issue of relations and mapping and relations, it's going to be very much easy for you to understand question 2. Which of the following equation defines y as a function? Okay? Like I said, you can have a lot of values of x giving you one value of y. That's possible. Okay? You you get my point, right? Are you getting my point? Or you are still not getting. So if you understand that part, it's going to be easy. Now, for you to know that this function defined y as a function, I can okay, I'm going to use two methods to teach you that. So you choose yourself which one to go with. Okay, you will choose yourself, but it's not hard. Which method do you know yourself, if I may ask? Which method do you know? Okay, so now it's just a matter of making y as a subject of formula. If y is alone, y is not squared, then you should know that it defined as a function of y. In short, if y is squared, don't you think that you are going to have two values of y? Definite, right? Guys, if you have got a function like this one here, y is equal to x squared plus 4. The moment this is squared, you're going to have two values of x. But still, y is not squared, so we're going to have one value of y. Definitely this function defines y as a function. So for any function, make y as a subject of formula. If y is squared, then that does not define y as a function. Is that okay? What I mean here is this: if you have got a function here, for example, the first one here, this one, if I'm to sketch this one, 4 is there, so it will be like this. And this one is making sense. But if y is squared, meaning we mean that the range we have got two values of y, which is not making sense. So it does not define y as a function. So this question is very simple and direct. So the first one defines y as a function. The second one, no, does not define y as a function of x because y is squared. What of this one? What of the third one? Hmm? Ella. What of the third one? Does it define y as a function? Yes, why? So for you to define that this is going to be is going to define y as a function. For any value of x, when you plug in, you need to get only one value of y. You can have you can have different value. You can have three, you can have two values of y, of x, sorry, but they'll give you one value of y. So in short, that's why I'm telling you to say in simple terms, as long as y is squared, that does not define y as a function. Okay, so this defines y as a function, this does not, because y is squared. So we're not going to get one value of y. Is that okay? Okay, so we are done with this one. We can go to the next one. This is the simplest one. Now question 3 is saying, given that the function f of x is equal to that, find f of 5. What does it mean? Where did x put 5? Find the value of x. Find the value of f of 5. This one was even there, grade 12. Should we solve it? Okay, which one should we solve here from question 3? So we have got x to a power 5. Now what does it mean here? What it means is where there is x put 5. So it will be 5 squared. It will be 5 to the power 2 minus 4, 5 plus 2. So 25 minus 20 plus 2. What's the answer? 5 plus 7. So I believe you can do this one. Then this one is just to put where there is a, where there is x, put a. So it's f of a to the power 2 minus 4a plus 2. This is the answer for the third one, this one. Then the fourth one is f of a plus b. Where there is x, put a plus b. Simple. So I'll say a plus b, but it is squared, minus 4a plus b plus 2. If you want to waste time, you can expand. A times a is a squared, but if you don't want to waste time, you end there. This is the answer. Okay? But if you want to waste time, you can say a times a is a squared. This is going to be ab plus b times a, again ab, then b squared minus 4a plus or minus 4b, then plus 2. If you want to waste time, then you can say a squared plus b squared plus 2ab minus 4a minus 4b plus 2. If you want, you can end there. If you want to waste time, that's what I've said. So you can end there, or you can go all the way there. It's the same thing. The next one is f of a plus f of b. What does it mean? At the first place, put a where there is x, then add it again, put b. Then you say a squared minus 4a plus 2 plus. Initially here there is plus, that's why I'm not going to put any brackets, because plus will not affect anything. But in a case where there is minus here, you put a bracket. Then you say b squared. Okay? Then minus 4b plus 2. Like that. So the final answer is just the same. Plus b minus 4b plus 2. Then you add this and this guy. So the final answer would be 4a minus 4b, then plus b squared, then plus 4. You end there. We're okay? Now before you continue, I want to show you how you can access the full tutorial sheet solutions and also some more practice questions and full topic videos on our site. So if you go to Chrome, then you go to your Chrome, then you search Transcended Institute, even just on Google. Okay, so if you search Transcended Institute, you'll be able to find this website here. So if you go on our website, you come here. So if you have got an account already, it's easy, but if you don't have an account, you have to create an account. And then I'm going to show you for mathematics. In this case, if I click on math, we have got math past papers. The first part here is just some introduction of sets, and then if you go down here, you'll be able to see the past papers for mathematics. The videos, the past papers we solved, they are all here. Let me show you. If you come down here, then this tutorial sheet is for 1120. Then you have got the past papers for last year, both 1120 and 1100. We have got the full topic videos for set theory, then the functions. For example, if you want to understand more on the relations and functions, like for the first question, you watch this video, 23 minutes. You want to understand more on one-to-one functions, you watch this video. The inverse function, composite function, basics of the function, domain and range of the function, then domain of the radical function, graphing radical function, domain of rational function, range of the rational function, how to find the x and y intercept, graphing function, rational functions, the piecewise function, the one we are from doing. The one we are going to do actually is question 7, I think 7 or 6, somewhere there. Completing square method, question the even and odd function, which is question 7 from this tutorial sheet. So it is very important for you guys to access these videos. They will really help you. Okay, so we also have some tutorial sheet here down. Then the question, the one we're solving for the application of radical function of the quadratic function, is also here. You can also get it. We have got tutorial sheet for 1120, that is tutorial sheet 2, 3, and tutorial sheet 4. All the answers are here. So you'll be able to access all these tutorial sheet solutions at only 80 kwacha per course per month. So if you want to access all these videos, you can just get in touch with us using this number here, +2607 67 729927. So you'll be able to register with us. You just WhatsApp this number. So let's continue. We go to part 4. These are type of questions where they just put there in the tutorial sheet just to waste your time anyway, but it can't come. Such questions. Okay, so now for each of the following, find and simplify. So find g of h. Where there is x, put h. There is nothing like, it's just g of h is equal to h. Done. Do you think they can bring this question? It's not possible. Then for each, again you find g of h. Again, where there is x here, put h. Yes, please. Okay, so the question is find g of h and simplify for each of the following. So for this one, for this one, you find this for all of them. Again, you find that. Again, you find that. You've seen it? So for the first one, g of h, just put where there's x, put h. That's the answer. Then the same one where there is h, put x plus h. So g of x plus h is equal to x plus h. It's done. Even here you do the same thing. In the square root, first put g, and you are done with that one. The second one, put x plus h, you are done. The only interesting question is the third one. It's the one I'm going to solve, where we have g of x is equal to negative 2x squared plus 3x. Let's first find g of h. So g of h will be equal to negative 2h squared plus 3h. I'm done with the first part. The second one, g of x plus h, will be equal to, where there is x, put x plus h. So it will be negative 2x plus h squared plus 3x plus h, like that. There is nothing like wasting time to simplify this, because even if you expand, you still end up having the same thing. So better just leave it here. Don't waste time. Then again you find this. What does it mean? Where there is x, you put so you say g of x plus h, you say g x plus h plus or minus of which this is a formula for calculus now. Negative 2, where there is x, just put everything here. So you say where there is x, you put x plus h, like that. Then minus again, where there is x there, you put again what? Oh no, here where there is x, where is it? Oh yeah, it's the same one. We put this, then we square it, then minus g of where there is x, we put again g of x. Which is what? I'm going to say 3, then I put x, like that. Then you divide it by h. If you want, you can expand. You expand. I think if you expand, it will be easy, and you are going to get the answer. Should we expand? Such questions can't come. Okay, let's expand. So you are going to have x squared plus xh. Okay, but again it will come back to this. I think the best way, which I wanted to show you, which one is that, which one is that, which one is that, especially for this part here. Yeah, for this one. If you are to solve that one, you'll be able to simplify. But you ask me, this question can't come, just for the sake of practice, because this formula is for the calculus issue. But let's understand the principle. I want you to understand this. For the first one, especially the first part, for us to find g of x. Now, you say this is going to be the same as x plus h, then minus again x, like that, then divided by h. So x and x can go, will remain with h over h, and you end up having 1. You have seen what I've done? Have you seen what I've done? Yes. So even here, where there is x here, you start now replacing this. Where there is x, put x plus h, then again that over h. Just leave it there. No one is going to penalize you. No one. It's the same even here. Just start plugging in the values. My main interest is, I think, on this question. This question. A field is to be marked in the shape of the rectangle. This question, whether you like it or not, is going to come both for your test and the exam. A field is to be marked off in a shape of a rectangle with one side formed by a straight river. If 100 meters is a variable for fencing, express the area of the rectangle as a function of the length of one side of the two equal sides. Sometimes understanding the question is one of the important things. If we have got a rectangle, let's assume that this is x, because they're the same. Then this is y, this is y. We have been told that the total, you want to fence the whole of this rectangle, but the total meters which you have is 100. So what's that total? Is it the area or perimeter? Come on, guys. Is it the area of the perimeter? We're talking about the total area. Sorry, the total distance. So we want to express area of the rectangle as a function of. So now, area is given by x times y. In this case, we have got x and y. So area is going to be x times y. Then the perimeter is the total distance, meaning is x plus y plus y. So the perimeter is the total distance which you have been given, which is 100. X plus x is 2x. Then this will be 2y. Before I continue, do you have questions? Maybe someone can ask me to say, why, how did you know that 100 is the perimeter? So I'm able to know that 100 is a perimeter because when we're talking about, they're saying that if 100 meters is a variable for fencing, because the question is saying if a field is marked off in the shape of the rectangle with one side formed by a straight river, meaning that the length of this guy from here all the way to reach again, we come there, a rectangle reaching there, the total is 100. That's the reason why I've concluded that 100 is the perimeter, because it's the total meters which I have to fence the whole rectangle. So that's how I've known that this is the perimeter and not the area, because area is L times B. In this case, x is my L, y is my B. We are good to go. Again, the question continues to say, express the area of the rectangle as a function of the length of one side of the two equal sides x. We know that one side has got two equal sides, which is this and this, and they want us to express area in terms of x. What does it mean? Meaning that for the perimeter part here, I want to express this as a function of x. So now for the perimeter part here, make y as a subject of formula. Then when you make y as a subject of formula, you come here and plug in the value. As simple as that. So I'm going to shift this to the other side. That would mean to say it's going to be 100 minus 2x is equal to 2y. Divide both sides by 100 by 2, even here by 2, meaning y will be equal to 50 minus x. Who is behind here? I'm just making y as a subject of ML. We're okay? Are we okay there before we continue? Yeah, so now allow me to get rid of this. We are saying a is equal to xy. Where there is y, put this, meaning y has disappeared, x will appear. So a as a function of x will be equal to now x, where there is y, put 50 minus x, like that. So a as a function of x will be equal to 50 times this is going to be 50x minus x squared. So you can rewrite this and say it's the same as negative x squared plus 50x. That's the answer. This question came in 2022, 2023. Tutorial sheet for last year, it was there. I also solved this question, and I'm going to send you the the, the, the video right now because I solved this. For those who access the videos on the website, I believe you have watched the same question just like this. Not so. Do you have questions? You're not clear on what? We were just trying to make, okay, here we are trying to make y as a subject of formula. So that we plug in here because we are trying to make this function in terms of x. The function a is equal to xy. So we're trying to make x as a y as a subject of formula so that y should disappear. We only remain with x in area. So this question, I was thinking maybe is if it is okay for you if I can solve this part C, because this question is just asking us to draw the graph of the following, just to sketch part 1 and 2. But part 3 is asking us to sketch, then again to find the domain and range, and also to find the values of g of 10 and g of 1. So I was thinking if I can teach you how to sketch this one, and then you go ahead and sketch part 1 and 2, then you send me the answers. How is it? Or you want us to do everything? You want us to do everything? I'm looking at time, because that would mean to say we're not going to cover everything, because we have to go all the way to question 7. So if we are to do everything, do you think we're going to reach there? What I mean is this: if I teach you this part here, which is part C, the same question but part C, it will be very much easy for you to sketch part 1 and 2. Okay, I don't want you to come and start crying. Okay, let's do it. So draw the graph of the following function. That is part what? Part 6, question 6. Draw the graph of the following function. Guys, this is what we call a piecewise function. Sketching a piecewise function is one of the simplest sketching in math, because you just follow the principle, you just follow the conditions which have been given. For example, the first part here, you have this. This is my graph, and we have been told that you have to make this a simple. So you have x, y. They are saying that for x should be greater than or equal to 0, meaning that starting from 0 going there. We don't know where we end, but we can just get 3 coordinates. It's fine. What does it mean? If I put 0 in this guy here, I'll still have 4 because I don't have x value. Again, if I put 1, I'll have 4. If I put 2, I'll have 4. I'll have 4. You get what I mean, right? Because I don't have any value of x, y here, meaning for any value of x, when I plug in the values, I'll still end up having 4. Because I don't have x, so I'll just have 4. What does it mean? It means that if I want to sketch here, let's have 0, 1, let's have 2. Meaning that if I have got my 4 there, now at this point is telling me to say greater is telling me greater than or equal to, meaning that at that point it is included where it is starting from here. So I'll sketch and say it is included here going this side. I don't know where it ends. I put an arrow. Putting an arrow indicates that you don't know where the graph ends. Okay, I'm done for the first part. Next, they're telling me to say x is less than 0, meaning that at that point it is not included. X, y. How I can get -3, -2, -1, 0. But 0 is not included, so it's going to be open at that point. So I'll just go here and put -1, -2, -3. But still I'll end up having down here, I'll end up having 4 because I don't have any value of x. I'll end up having -4. Meaning that it will just keep on going there. We don't know where it ends. But at that point it has to be an open circle going there. That's the graph of the first part. Any question? This is one of the simplest graph. You should know. One of the simplest graph you should know is piecewise function. Okay. Then you can also use the same principle to sketch the second part, of which I'm going to sketch for you. So I'll first have, I've been told that x should be greater than or equal to 2. That means that starting from 2 included 3, 4, I'll still have 4, 4, 4 because I don't have any value of x. Next, xy. If I put, they're saying that the values should be from between -1 to 2. That's the meaning there. But both not included. So -1, then 0, 1, 2. Both, but at that point it should be included. But at this point should not be included. 0. So if I put -1 where there is x here, it still will be -1. No, it will be +1, sorry. Negative and negative will cancel, have 1. If I put 0, it will be 0. If I put 1, -1. If I put 2, -2. But at the first point, it is not included, also that one not included. The last one, xy. If I put, they're saying that less than or equal to -1, meaning that where it's going to start there, it is included. So -1, so less than. So that would mean to say I can start from -3. Should I start from -3? Yes. -2, -1. But at that point it is included. So now I'll start. If I put -1 where there is x, -1 plus 2 is 1. If I put -2 where there is x, it's going to give me 0. If I put -3, it's going to give me -1. Who is behind before I sketch? Who is behind before I sketch? No one? No one is behind. Okay. So when you have this now, you can come up with a sketching. So you do this, or the values, the highest values I have in y is 4. So I can do it like this. Put the numbers. In x, I can clearly see that I've got 1, 2, 3, 4. That's the highest one. What of the negative side? Negative side, I end to negative 3. So negative 1, negative 2, negative 3. Positive part of y, it ends to start from negative 1. Do we have 2? No. So I've got 1, 2, 3, 4. 1, 2, 3, 4. Negative part, it goes all the way to negative 2. Neg 1, neg 2. Now you can start sketching. I'll start with the first one. 2 comma 4. 2 comma 4 is here. 2 is there, 4 is there. Okay? 2 comma 4 is here. But at that point, it is included. So I'll do like this. Then 3 comma 4. Again here. Again there. We don't know where it's ending. You just put in a line there. Put an arrow. Because we don't know where it's ending. You are done for the first part. For this part here. Done. You go to the next one. So the next one, you discover that we have got negative 1 comma 1, negative 1 comma 1, but at that point it is not included, so you put an open circle. Next, 0 comma 0 is here, 1 comma negative 1 is there, 2 comma negative 2 is here. Is it included? No, it's not, so it ends there. That point is not included. Then you just put a line like that. You are done for the next one. Then another one, now you start negative 3, negative 3 comma 1. Okay, negative 3 comma 1. Where is negative 3? It's here. Negative 3. Oh, so I can extend this and put negative 3 here down. Negative 3 comma negative 1 is here. Negative 2 comma 0 is there. Oh no, negative 2 in x, sorry. Negative 2 in x. Okay, then 0 is supposed to be here. Then this one we said negative 3 in x, then negative 1 here, so it's supposed to be, let me start it again. We are saying negative 3 comma negative 1 in x, negative 3, then here 1. Okay, so it's here. Then negative 2 comma 0 is there. Negative 1 comma 1 is there, but it is included, so I'll put it inside there. So that one goes like that. You put an arrow. So that's the graph. Have you seen it? That's the graph of that function which we have. Any question? But again, don't you think that, just a minute, the one in between, we are saying that is starting from 1, it ends on 2, which is cool. Okay, it's just okay. Because at that point it's supposed to be open, even here open, because that is the same as negative 1 not included to 2 not included. That's why I said if I do this, it's the same as I just do this. So this one you can now sketch, not so. You can sketch this one. Yeah, you can sketch. Now when you sketch this one, then they want you to find the domain and range. Domain, these are values of x. Okay, let's just do it together, because this one has got high potential of coming. Let's do it for the first one, x, y. So the x now, for the first one we have got negative is less than or equal to. So I'll start with negative 3, negative 2, negative 1. So if I put negative 3 here where there is x, it's going to be 1 minus minus 3, which is 4. If I put 2, it's going to be 1 minus minus 2, which is 3. Here 2. For the first one we are done. But at negative 1 comma 2 it should be included because it is less than or equal to. Next, xy. We have been told that start from negative 1. As long as we have got two values here, meaning start from this point, end there. That's the meaning. There is no two way about it. So we're starting from negative 1, 0, 1. You end there. But at negative 1, it is open. So if you put negative 1, you still get 2, here 2, 2. Because I don't have the value of x here, I just have a number. Then at that point, at 1 comma 2 is supposed to be also open. The last one, saying x is greater than or equal to 1. Starting from 1, 2. I'll just end on 2 is fine. No one is going to penalize me. I can go all the way to 3 if I want to waste time. If I put 1, 1 squared is 1, 1 plus 1, 2. But at that point, it is included because of greater than or equal to. If I put 2, it's going to be 4. 4 plus 1, 5. I'll end there. Because 6, that is going to be 9, 9, 10. So 10, it can waste my time. After doing this, come up with the graph. Let's do it from here. So I'll start with the first one. In x, we have got negative the color I'm using. Okay, but I feel like it's the one which is bright. What of the white? If I use the white one, you're able to see. Okay, so now you see it from here. I'm going to use white, negative 1, negative 2, negative 3. Then the positive part, it goes all the way to 1, 2, 3 as well. 1, 2, 3. The y part, the highest number is 5. The lowest number is, we don't have a negative. So we have got negative 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, like that, not so. So we start with the first one. So the first one we are starting with neg 1 comma 2. Neg 1 comma 2 is here. Is it included? Yes, it's included. Like that. Then neg 2 comma 3 is here now. I'm going there. Neg 2 comma 3 is there. Neg 3 comma 4. Neg 3 is here. 4 is there. We are here. So the first part, starting from there, going there. So you put an arrow because we don't know where the graph is ending. Done for the first part. Next, I'll go here. I'll start with 1 comma 2 because That's the point where it is open. So this is included. I need to show that it's included. Negative 1 comma 2, it is not included at that point. Then I'll put an open circle now for now. Then what of 0 comma 2? 0 comma 2 is here. 1 comma 2 is there. Is it included? No, it's an open. You put an open there. I'll put an open. Then just put a line like that, meaning you are done with that one. Next, I got the next one. 1 comma 2, it is included at that point. So inside there again I need to put another one, but included. Next we had the 2 comma 5. So 2 comma 5 is here. So I get an arrow, I just start from there going this side, then put an arrow because we don't know where it's ending. That's the sketching of this guy. So for the first part, which is saying sketch the graph, I'm done. Any question? Do we have any question? It's okay, right? Then the second one is saying state the domain and range. The range, these are values of x. So the values of x, guys, we don't have any open circle. Inside here, we have got open. Let me show you. This is open, but again, inside the same part, it is closed. So that's why it's not jumping. Again, here it is open, but again, inside it is closed. It's not jumping. Therefore, the domain is from negative infinity to positive infinity. Because it's not jumping, it's just open. In a case where you have got, if we had this, like that, it's open, then you have to jump this point because it's not part of it. So I would have jumped here, I would have said negative infinity to where the point is in x negative 1. Then I say union, again negative 1 to 1, union again 1 to positive infinity. But since inside again is included, that's why I'm going to say it is from negative infinity to positive infinity. The range, these are values of y. Where is it starting from in y? Starting from 2, going up. So the range is from negative, or from 2 included, all the way to positive infinity. Simple, right? The last question is saying find the values of g of 10. Now g of 10, again this one came in 2022 for 1124 SAP. For g of 10, you check here which condition is including 10, negative 10. The first condition is saying x is less than or equal to negative 1. From negative 1 going all the way to negative infinity. For you, this is where negative 10 belongs. So I'm going to say for f of negative g of negative 10, I need to get the first one, 1 minus x. So it will be 1 minus negative 10, which is 11. What of g of 1? Which function include 1? It's the third one. Because it's saying x is greater than or equal to 1. So 1 is included. So put 1 where there is x. G of 1 will be equal to 1 squared plus 1, which is 2. What of g of 10? G of 10 still, I'll go forward for the same function because it's saying x is greater than or equal to 1. So 10 is included in the third one. So it will be 10. So it will be 10 to the power 2 plus 1. 100 plus 1, 101. As simple as that. Unless you have got questions.